When same objects are grouped together having same characteristics, those are called as class. Very simple. Now, at your home, you arrange things together, your clothes separately, your shoes separately. And that is a class of clothes, a class of shoes. And similarly, we separate things at various stages. For example, even during your school life, you have class 3, class 4, class 8. That means students of the same age group, same mental group would be kept together. And this is how class originates. Now, this class can have relation with other class. Now, when there can be a relation between two classes, we call it as a categorical proposition. This relationship can either be positive in nature, it can be a negative relation, it can be a whole relation or a part relation, and that is explained under categorical proposition, which we would understand in the next section. For now, we understand what are classes and how do we establish relation between classes. So, when I say class, there can be a class of triangles, there can be a class of circles, there can be a class of bananas, and there can be a class of parrots. So, I am trying to group objects together based on their common characteristics. Now, when I am grouping them together, they can either be wholly included in one another, they can be partly included, partly not included, or totally exclusive from one another. So, let's understand these categories one by one. The first classification we understand is wholly included. When I say wholly included, that means I have two classes and one of the class is wholly included into another. For example, I say all cats are mammals. Now there can be one scenario where this is the cat and these are the mammals. So all cats are part of the bigger group, which is mammals. Or there can be a scenario where all cats and mammals overlap. That means I say all cats are mammals and all mammals are cats. That means they overlap one another. If all the cats are mammals and they overlap, then I can say all the mammals are cats as well. So, we call this as the wholly included explanation. Now, I have explained this by a Euler diagram. There are two ways of explaining logic, either through a Euler diagram or through a Venn diagram. Under a Venn diagram, we try to overlap two circles, and this concept was given by a logician and a mathematician, John Venn. And later on, his Venn diagram theory for logic became one of the major theories for interpretation. The next case that we study is partly included. Partly included, that means I take the same example but I change from all to some. So I say some cats are mammals. Now when I say some cats are mammals, so these are mammals. This is a predicate. P means predicate, S means subject. So cats. Now some of the cats are mammals. That means cats can lie in this region, or there can be a bigger circle which indicates the cats and a smaller circle which indicates mammals, and I can say some of the cats are mammals which lie in this region, and those cats which lie outside the region of mammals are not mammals. So these are the two cases which I say can be partly included. The first case is explained through a Venn diagram, which is an overlapping diagram. The second case is explained through a Euler diagram. Euler diagram is most successfully used when we have multiple statements or the contours increase. The contours increase means the number of circles that we are drawing increases. Then Euler diagram makes it easier for interpretation in contrast to Venn diagram. Don't worry, we'll cover Venn diagram and Euler diagram separately in a separate lecture, the difference between the two. The next is partly not included. Partly not included or partially not included, whatever you can say. The idea here is I make a statement, some cats are not mammals. Now when I say some cats are not mammals, I have a circle for mammals, I have a circle for cats. and I say some cats are not mammals, that means the cats lie in the region X which I have marked, because in the other region the cats would tend to be mammal. So this is one of the cases, and this is proved through Venn diagram, which we would understand again in our categorical propositions. The next is the circle of cat and the circle of mammals. Now I say some cats are not mammals, that means some of the cats which are lying here are not mammals, and this is a successful case that I explain here, which is partly not included. The last case that we take into account is an exclusive case. Exclusive case, when I say none of them have any point of intersection, so I say no cats are mammals, that means cats and mammals are exclusive in nature. Both of the circles would be separate. I can take example of another example where I say no triangles are circles. So triangles would be separate and circles would be separate. There would be no point of intersection, and this is known as excluded. So class, to summarize, is a group of objects, a collection of objects which have similar characteristics, and when we try to establish relationship between two different classes, it can be wholly included, partially included, excluded, or partially not included. So that is a basic introduction to our theory on logic. We would understand Venn diagram, Euler diagram, and categorical propositions in further details in next lectures. Stay subscribed.